may delete the information which is stored in the database. Every time any of these action is performed by the user, a trigger will be fired. A trigger files in response to an event like insertion, updation and deletion of data. Trigger help in maintaining consistent, reliable and correct data in the tables. They enable the performance of complex action to other dependent tables. So triggers are basically statements which are fired as a side effect of the modification which is done to the user, and it is mandatory that this modification is done by using DML commands which are insert, update and delete. And the user can design trigger by itself also. In order to design a trigger, we must specify the conditions under which trigger is to be executed. First of all, you will have to specify the conditions under which the trigger will be executed. For example, you will specify you want to fire a trigger whenever an insertion is done, or you want to fire a trigger whenever updation is done, or you want to fire a trigger whenever a deletion in the database is done. So it is broken up into an event that causes the trigger to be checked and a condition that must be satisfied for trigger execution to proceed. To specify the conditions in which the trigger will be executed, you will specify an event which causes the trigger to be checked, and then you will specify a condition which must be satisfied for trigger execution to proceed. Then second, you will specify the action to be taken when trigger executes. First of all, you will specify the condition under which the trigger is to be executed. Secondly, you will specify the action which is to be taken when the trigger will be executed. In such a way you can design a trigger. The database stores the triggers just as if they were regular data, so that they are persistent and accessible to all database operations. For example, the database will be having a number of tables in it at any given instant of time. The database stores the triggers in the similar manner the way it stores its tables or relation. And the reason behind it because they are persistent and are accessible to all database operations. Later on, if database want to use these triggers on any other parts of the computer, it may use them because they are persistent and they are the permanent part of your database. Once we enter a trigger into the database system takes on the responsibility of executing it whenever the specified event occurs and corresponding condition is specified. Once you have designed the trigger and you have entered the trigger into the database, then the next responsibility, if it is of your database, that database will take care of that whenever an event is occurred, at that particular time the trigger is fired. The next are the characteristics of a particular trigger. What are the characteristics of a trigger? It can only be associated with tables. Simply it specifies you cannot associate triggers with any other thing other than tables. Whenever you will specify a trigger, you will specify that particular trigger on a particular table only. You cannot specify the trigger on columns or rows or attributes. Second is, it cannot be defined with temporary tables or views. However, it can reference temporary tables and views. Temporary tables are made for a temporary use, and the views are basically a logical table which is derived from an inbuilt table. So whenever you are defining a trigger, it cannot be defined with temporary tables or views. It will be defined only with the permanent part, which are persistent part of your database. And the next is, it is fired automatically by SQL server. SQL stands for Structured Query Language Server, whenever any data modification statement is issued. The triggers will be fired automatically by the SQL server whenever the modification is done to the database by using any kind of DML statements like insert, update or delete. Next characteristics is it cannot be explicitly invoked or exempted as in the case of stored procedures. We can compare the triggers and stored procedures, but they are two different things, because the stored procedures can be invoked by the user or they can be stopped by the user, but the triggers cannot be fired by explicitly and they cannot be exempted by the user. And the next is triggers can be nested up to 16 levels. You can nest them up to 16 levels. You can specify number of triggers, and the nesting of triggers occurs when a trigger performs an action that initiates another trigger. Here we mean that whenever you have to do the nesting of triggers, and it will occur only when a trigger performs an action which will be initiating further any other trigger. Third characteristics is it prevents incorrect, unauthorized and inconsistent changes in data. By firing a trigger in your database, whenever a modification is done to your database, by using triggers you can prevent the incorrect entry of your database and unauthorized view of your database and any kind of inconsistent changes in your database. And the last characteristic of a trigger is it cannot return data to the user, as the store procedure may return the data to the user and functions can also return the data to the users, but it is noticeable that triggers will not be returning any kind of data to the users. And the next topic is relational integrity. There are two important integrity rules that apply to all instances of the database. These two principal rules are entity integrity and referential integrity. Before understanding these two, we need to be aware of the concept of null values. What are null values basically? A null can be taken to mean the logical value unknown. By definition, null represents a value for an attribute that is currently unknown or is not applicable for this tuple. It can mean no value has yet been supplied. A null is not a zero or a text string, because zeros and strings are values, but a null represents the absence of a value. Therefore, nulls should be treated differently from other values. Sometimes people may confuse the null values with zeros and the other text strings like hash and dollar signs, all these things, but we need to differentiate between the both, because the zeros and the string values are text strings are considered to be values, but a null will be representing the absence of a value. Whenever you leave a column blank, that will be considered as a null values. So therefore the nulls should be treated differently from all other values. Now we will discuss the two integrity rules which are to be used in order to maintain the relational integrity of a particular relation. First of all, entity integrity. This rule applies to all the primary keys of the base relations. Base relation means from which you can derive the values of the foreign key. In a base relation, no attribute of a primary key can be null. First of all, you need to take care that all the primary keys are having unique values, and other than that, in a base relation, no attribute of a primary key can be null. That means the primary key column should not be left empty by any of the users. If in case it happens, it will be the violation of entity integrity rule. Next is referential integrity. This rule applies to all the foreign keys. Foreign keys are the keys which derive their values from primary keys of other tables. If a foreign key exists in a relation, either the foreign key value must match a candidate key value of some tuple in base relation, or the foreign key value must be left null. Here is a condition which states that all the foreign key values should match with the values with the primary key, or the foreign key value must be left null by the user. That means no value should be entered in that particular column. So that's all. Now we will revise the today's chapter. What we discussed in today's chapter is a relational database consists of a collection of tables, each of which is assigned a unique name. Relational database will be having a number of tables made of rows and columns, and all having one unique name, and no two tables should be having same name. A relation is a table with columns and rows. Columns are said to be attributes and rows are said to be tuples or records of a particular table. And the attribute is the named column of a relation. For example, if you are storing information about student, the name of the student, address, class, all these will be attributes of a relation. The total number of columns or attributes present in a relation are considered to be degree of that relation. Extension, it is the set of tuples appearing in the relation at any given instant. The number of rows present in a relation are known to be extension. The other thing is intension. The intention of a relation is independent of time, because it is the permanent part of the relation. It is combination of two things, naming structure and integrity rules. Naming structure consists of the name of the relation and attributes name, and integrity rules specify the various type of constraints which are to be applied on the data which is to be entered in the database. Next are the relational constraints. Constraints are basically certain rules and regulations which are to be applied on the data which is stored in the database, and relational constraints are constraints which are to be applied on the relations, on the tables which store the data. There are various constraints: domain constraints, entity integrity, and referential integrity. Domain integrity ensures that only a valid range of values is allowed to be stored in a column. No invalid value will be entered in your database. Entity integrity specifies that each row can be uniquely identified by an attribute called primary key. All the relations in the relational database should be having this particular column, and along with it the primary key cannot be null. You cannot leave the primary key attribute empty. Next is referential integrity. It ensures that all the values in the foreign key match with the values in the primary key. Whenever a table is not having a primary key, then it derives the values of the primary key of some other table. In that case, the values in the foreign key should match with the values which are given in the primary key of the other table from which it is having these values. And next is assertion. Assertion is a predicate expressing a condition that a database always satisfies. These are some sort of condition which are given by a database, and the data which is satisfying this condition, only that will be allowed to enter in your database. And the last is, what is a trigger? Trigger is a statement that a system executes as a side effect of a modification to the database. Whenever you perform any kind of modification by using any kind of DML statements like insert, update, or delete, whenever you will insert some sort of data or delete some sort of data or update the contents of your database, as a side effect the trigger will be executed by the system. So that's all for today. Thank you.